Hello, Mr. Minnick helping students learn how to represent digital electronics with Boolean algebra. Here we go with an exercise that's asking you to write a Boolean expression for the given digital electronics diagram. So we have variables A, B, and C, and you can see the A on that path where I'm waving my mouse. There's a not operator. These operators, of course, can be found on our digital electronics study guide. And the not, for example, is right here where I'm waving my mouse. So I'm going to begin building the answer here by just putting a little A, capital A, uppercase A, with a little not bar. Boolean algebra, of course, we studied earlier, perhaps this school year, by studying the Boolean algebra guide and the notation specifically that's used with Boolean algebra. Right here are some identities that will be handy later on in these exercises. So that's been represented right there as an A naught. So I'm going to sort of like I use that up. Now this is an AND gate, and the B is coming in from the right, from the bottom. So I'm going to use that as the bottom side. This represents multiplication. And then that as a whole is going into this gate. Well, what the heck is this? I see that this is a concave curve as opposed to this AND gate that was a straight. And I go over to my, and it has a little not dot on it. So what is that kind of gate? Oh, it's not being represented here. So it's an exclusive OR, which isn't showing up correctly here. There should be another little line here, and it didn't come through, so I'm going to have to look into that. Anyway, by the time you watch the video, that'll be fixed. So we have a C coming in here sort of from the right, but this operation is the exclusive OR, so it's represented in Boolean algebra with that notation. And then all of that is being knotted. So the exclusive OR is like the double curve part of this. And then this is the knot over the whole pair of operands that are around this gate. So this little dot is represented by that long bar. This little dot is represented by that bar, by the way, and that's the final answer. Now, you could break it up and simplify it, but I think that this technically would suffice as an answer to any of my worksheets. Number 2, let's quickly do the same thing. This A and B, that's a straight piece there, so that's A times B. And down here we have a C ORed with a D, so that's a C plus a D. Now, you should be safe and put parentheses around that OR, because OR is relatively low on the order of operations. So let's be safe with that set of parentheses. You could put a set of parentheses around this. If you really want to be safe, you could. But now this operation and this operation are being joined with this exclusive OR. So we need to put an exclusive OR in there. And if you're not sure about order of operations, I guess you would put the parentheses here to be sure that's executed first. After all, it was all done up here before it went into this. And last of all, this is simply a not operator, which means that this whole kit and caboodle, this whole set of operations coming in here is being knotted. So there's your final answer for number 2. Number 3, in the process of finding the ordered triples that make this right here true, we must first translate this diagram into a Boolean algebra expression. Well, this is easily decipherable as A plus B. We better